All right, if you're gearing up for the National Professional Practice Exam, the NPPE, you already know that the definition of engineering isn't just some paragraph you have to memorize. No, it's way more than that. It's really the legal and ethical foundation for the entire profession here in Canada. So today, we're going to tear it down and see what really makes it tick.
So, let me ask you a question to get us started. What's the real difference between building a bookshelf in your garage and designing a massive bridge? I mean, they both involve some planning, some materials, and putting things together, right? But the difference is huge, and it all comes down to scale, responsibility, and who might get hurt if you get it wrong. One's a weekend project, the other, well, that's a public trust.
And that right there is the key. In Canada, when you call yourself an engineer, you're not just saying what you do for a living. It's a protected title. It's a legally binding promise you're making to society, a promise that's baked right into the law in every single province and territory.
Okay, so here's how we're going to tackle this. First, we'll look at why this is all locked into law. Then, we'll perform a little anatomy lesson on the definition itself. After that, we'll check out the engineer's core toolkit. And finally, we'll wrap up with the professional mandate that this all leads to. Sound good? Let's do it.
First up, that promise cast in law. You gotta understand, the Canadian definition of engineering isn't like what you'd find in a dictionary. It's not just describing what engineering is, it's prescribing what it must be. It legally defines the job and draws a very clear line in the sand about who's responsible for what.
So now that we get the legal weight behind it, let's actually look at the definition itself. I know, when you first see it, it can look pretty dense and full of legalese, but trust me, we're about to break it down into a few simple, easy-to-remember parts. Okay, so here's a chunk of the official text. You see all these words like advising, reporting, and then that super important phrase, safeguarding of life. It looks like a bit of a word salad, doesn't it? But stick with me, because there's actually a really elegant and logical structure hiding in there.
You know, the easiest way to get this is to think of the entire definition as standing on three main pillars. It's that simple. You've got the activity, that's the what engineers do. Then you have the object, that's the why they do it. And finally, the foundation. That's the special knowledge they have to use.
So let's look at that first pillar, the activity. Just think of these as the verbs of engineering, the action words. We're talking about designing, planning, evaluating, supervising, all of it. If you're doing any of these things, and public safety is on the line, you are legally practicing engineering. These aren't just items on a job description, they're legally protected functions.
Now for pillar number 2. The object. This is the big one. This is the purpose. It's the why behind all those actions. This is the absolute, non-negotiable, ethical heart of the profession. Every single design, every calculation, every report has one ultimate goal: safeguarding the public, period.
And that brings us to our third pillar, the foundation. This is the stuff that makes professional engineering different from, say, a technical trade. It's the absolute requirement to apply scientific principles, math, physics, chemistry. It's all about deeply understanding why something works from the ground up, not just knowing the steps to put it together. So, we've got our three pillars, right? The what, the why, and the how. Now let's see how those abstract ideas actually turn into the real-world, day-to-day toolkit that every professional engineer uses.
Let's take the word advising. This isn't like giving your friend advice on what phone to buy. We're talking about providing expert, technical judgment that carries real professional weight and, legal accountability. Your advice shapes big decisions, so it has to be rock solid, objective, and based on facts. Then you've got evaluating. This is so much more than just ticking boxes on a checklist. It's a deep, systematic analysis. It requires you to have the technical chops and, just as importantly, the ethical integrity to stand up and say no if something isn't safe or up to snuff. And of course, designing. For a lot of people, this is the very heart of engineering. It's where all that creativity and innovation comes in. But it's always tied to that profound moral responsibility to keep the public safe. You could say every design choice is also an ethical choice. And this is how those big, scary science subjects become everyday tools. Math isn't just theory, it's the language you use to model the world and predict what's going to happen. Physics isn't just some class you took, it's how you understand the very forces you're trying to control. And chemistry, that tells you how the materials you're using will actually behave in the real world. Okay, let's put this all together. When you combine the what, the why, and the how, you get the professional mandate. This is where we talk about the consequences of that definition, what it truly demands from you as an engineer. It really is an ethical line in the sand.
And here's the bottom line. That definition acts as a legal boundary marker.
It clearly spells out which activities are so critical that they legally require a licensed professional engineer, a P.eng, to either do the work or sign off on it. This is the system's core defense mechanism for protecting the public.
This chart does a great job of showing that boundary. A technician or technologist is a highly skilled professional who applies established procedures. But the engineer is the one who applies those foundational first principles and, crucially, holds the ultimate accountability for public safety. It's not about one being better than the other, it's about having very distinct, legally defined roles and responsibilities.
And really, if you only take one single thing away from all of this, let it be this. Everything else we've talked about, the advising, the designing, the science, it all serves this one single overriding duty: safeguarding the public.
So, why do you need to know this inside and out for your exam? Because this definition is the bedrock of everything. It's the reason for licensing and discipline. It defines your legal scope of practice. It's why engineering gets to be a self-regulated profession. And maybe most importantly, it's a statement about who you are as a professional.
The source material really says it best here. The definition is more than a rule, it's a statement of identity. It's the very expression of what it means to be an engineering Canada. A professional who applies science with an unbreakable ethical commitment to the public good.
And that really brings us to our final thought. The definition of engineering isn't just an answer you memorize for an exam. It's actually a question. It's a question that you, as an engineer, have to ask yourself every single day of your career. How is what I'm doing right now serving and safeguarding the public? Answering that, well, that's the real blueprint for being a true professional.